Hey everybody, this is Matthew Doyle for Autodesk. You're watching Maya LT 2017 Update 3 Part 2. In Part 2, we're going to be finishing up with the UV editor. We're going to cover the rest of the UV Toolkit features. Now bear in mind that most of these features have existed inside of Maya and Maya LT for a while now. I'm just going to basically show you where they're located inside the UV Toolkit and how to use them. We'll also finish up the video by covering some quad draw improvements. So in the modeling toolkit, Quad Draw has been improved in a number of ways. Specifically, visually, it looks better. There are more adjustments on how you can make the Quad Draw polygons look when rendered over a mesh, as well as some improvements in the multi-cut tool when working with Quad Draw polygons, and a few other things. So I hope you enjoy the tutorial, and we'll see you when it's over. Last week, we left off with the transform tools in the UV Toolkit. Directly under this, we have some of our tools: grab, pinch, symmetrize, lattice, and smear. Let's try the grab tool here, and you'll see what that does. It gives us a brush that we can adjust the size of, and then grab parts of our UVs and just kind of pull them around in a blended fashion here. Let's undo that. We can also pinch. So using the pinch tool, we can see we're squeezing those verts together, or those UV coordinates. We also have lattice, which allows us to draw a lattice with a drag box that we can then control using control points. We can distort our UV coordinates this way. Smear works similarly to the grab tool. We can smear out our UVs by dragging them out. Lastly, we have the Symmetrize tool. Now, the Symmetrize tool allows you to make sure that basically both sides of your UV space, so if, for instance, in the case of the head here, we can see that it's basically symmetrical from left to right. We could make sure that it's perfectly symmetrical, that the UVs are laid out in a symmetrical fashion using this tool. However, this mesh will not support this tool because it's not a symmetrical mesh. Let's go ahead and create a simple sphere that will allow us to show the symmetry tool in action. Okay, so now we have a sphere as an example. This is a perfectly symmetrical mesh, but the UV coordinates I've distorted a little bit, making this unsymmetrical in UV space. But let's say we want this particular topology here, these UVs, to be the same on this side as well. To do that, we'll use the Symmetrize tool. And first we need to set the topological symmetry seam. And I'm going to set mine right in the center here by selecting one edge here of the vertical UVs here. Now, we'll also see we have this black line here. This black line can be used to control the way the symmetry works. By putting it in the center, we're going to get an exact left to right or right to left mirror. If I move this over further to the left, we can see here that we're not doing it from the center anymore. Instead, it's kind of offset based on this line. Whatever we do over here will be offset based on this line. So let's put it back in the center because we want to copy exactly from this side to this side. So by painting over here, just clicking and dragging, we can see we're painting over and getting the same symmetry that we have over here. And that's the Symmetrize tool in a nutshell. Now, just as a quick example to see what would happen if we go ahead and move our line of symmetry here, go ahead and click and middle drag, control and middle drag to bring this line of symmetry offset from the center. And then we'll paint our vertices again over here, our UV coordinates, and you'll see we are getting the same mirroring from this side to this side. And it is, in fact, centered based on this black line. But it is offset because of our original line of symmetry being here. It's offset, and it creates some distortion here. Now, this may be what you're going for. This may be a way to get you to a certain point where you can then manually correct everything else. But that is basically how you use the black line of symmetry here to offset the changes. Let's have a quick look at some of the other tools, under tools: rotate, scale, and texel density. Rotate obviously allows you to rotate individual pieces, shells, UV coordinates, whatever the case may be. So if I select the head here, and then let's turn off soft select, and I'd use rotate, I can rotate based on this value here. Obviously, I can just use the rotate tool using the E key, and I can obviously adjust step snap. I can turn snapping on and off, and I can snap by certain increments. So this is 15-degree snap. I can make this 25 degrees. All right. And then, of course, scale works very similar. We have the different snaps for our scaling. We can turn snapping on and off. We can also scale by these buttons or just use the usual scale key. So, for instance, if I have this set to 2 and I hit scale, it uniform scales it by 2 each time I do that. I can also do it just in V or just in U. So we can see here I'm scaling just in V or vertical, and then horizontal would be U. All right. We'll go ahead and skip over the snapping part. It's self-explanatory. We've already explained that for the other rotate and move. Then we also have prevent negative scale. You'll notice when I do a scale operation, not a uniform scale, but any scale that's non-uniform, right now I can't scale past 0. So it's basically scaling these UVs down to a line. If I wanted to, I could turn prevent negative scale off, and that's going to allow me to flip the UVs by scaling. But prevent negative scale is on by default. And of course, we also have a flip button, so we're flipping the UVs, and then we can flip by U or flip by V. This next little box, this is texel density or pixels per unit. You can think of a texel as a pixel. It's just in texture or 2D space, whereas a pixel is on a monitor. Now, to find out how many texels your texture map is, or your UVs are taking up on your texture map, you can hit the Get button. Now, this says 32, but actually, if I hit the Get button, you can see here that we're taking up 3.8 texels. This is our texel density value. Now, I could change my texel density value using the set command. So I could set this to 32 and hit set. Now you can see that this particular shell that I had selected is now taking up 32 texels per unit. So you can see by raising this value, the texel density, we're actually making the UVs take up more space. However, if we change the map size, so in this case we'll set it to 1024, hit set again, it's going to reduce the size of the UVs because obviously we're working with a bigger texture map in this case. Back down to 512, hit set again, and again, it seems apparent that the UVs become bigger because they are taking up more texture space or texels on the texture map. Let's go ahead and undo that, take us back to our original values. So when we go ahead and hit Get, we can see we're taking up 3.8 texels per unit. So you're going to find that the UV Toolkit basically takes all of the UV editor tools and organizes them into a menu that is more consistent and more intuitive. And if you're used to using the modeling toolkit, I think you will find that that is true. So obviously we've already looked at all of the selection options and the pinning and transform options. And below that, we're going to find drop downs for things like creating UV coordinates. This drop down allows you to basically add UV coordinates to objects that haven't already been UV mapped. So you've got your usual automatic, cylindrical, spherical, planar mapping, and so forth. Below this, we have our cut and sew drop down. And we've got all of the tools used for creating seams in our UVs or sewing seams together. For example, I'm not going to show all of these tools, but for example, if you wanted to use the cut tool, if you're not familiar with this tool, you could simply select an edge on your UVs here. So we'll just select an edge down the front of the torso and then hit the cut tool. And that's going to actually create a texture border there or a UV seam. And then we could use the grab tool under our tools and just kind of adjust that. So let me make my brush smaller here and pull those apart. You can see that we've created that seam. And I could sew those back together too using the sew tool. So if I just go here and click sew, and then I can paint, select, and sew those right back together. And the cut tool works similarly to the sew tool in that it's an interactive tool for cutting things apart. You can see here I'm actually cutting the seam in a more interactive way rather than using just selection and hitting the cut tool. So those are the cut and sew tools. Below that, we have our unfold tools. This is, again, after you've created UVs on an object, or maybe you've got an object that has UVs, but they haven't been unfolded yet. You've got all your seams cut. You would go into the unfold tools here and use the unfold algorithm and so forth, or optimize tool and so forth. And these tools are, again, tools that have already been inside of Maya and Maya LT for a while now. Under this, we have our line and snap tools, so we can actually line up our UVs. So let's say we selected a shell here. So let's say we select this shell, and maybe we want to align it with something else. We can align it using our UV space, using these, just like the pivot. We can do left corner, right corner, middle, and so forth. Let's go ahead and undo that. We can also align UVs just like we can align mesh objects. So if I were to select this UV shell and this UV shell and hit this left align button here, it's aligning by the far left UV coordinate. I can also align by the far right UV coordinate. I can center both of them down the center here. And I can do the same thing vertically as well. Let's undo all of that. Now we have the Arrange and Layout dropdown, and this dropdown has all of the options and features for allowing you to lay out the UV shells in your UV workspace. So for instance, if we wanted to distribute all of these UV shells in a specific way, we could distribute them based on the direction here. So we could say we're going to distribute these rightwards along the U by pressing this button. So we'll let it do its magic, and now we can see that they've all been laying out horizontally, all of the shells to the right. So we'll undo that. We can also change the distribution. So I'm going to put a value of 1 here and do that again. And now we can see that each shell has been moved a total of 1 unit or 1 UV space in the right direction. So in other words, we have our usual UV space, our default UV space. That's the 0 to 1 space here. And each shell has now been moved into the next space over. So we have the first space, 0 to 1, for the head shell, and the second shell is moved over in the 1 to 2 space. Then we have 2 to 3, 3 to 4, 4 to 5, etc. So this allows for what's called a multi-UV space workflow, or a UDIM workflow. Let's go ahead and undo that. Some of the other options we have here are orienting the shells. We can change their orientation based on the most adjacent U or V axis. We can also stack the shells. They're all on top of each other here. We can unstack them. We can stack and orient. And finally, we can randomize the shells. So it's basically just putting the shells in different locations. There might be a purpose for this, perhaps creating some sort of effect. We can also make measurements. So in the case of this shell, if we do a measure, we can see the U and V distance based on the texture map size. So if we have a texture map that is 4K, we can see the U distance of our shell is 1663 pixels, and the V distance, or vertical, is 2327 pixels. We can change the distance here using the drop down. We can do U distance, V distance, pixel distance, and angle between. So if we do the U distance and hit measure, we can see that we're taking up 0.4 of our texture map's UV coordinates 0 to 1. So that would be from 0 to basically 0.4, and that is where it stops. Also, if we change that to the V distance and hit measure, we can see it's taking up 0.56. So if you were to move this down to right on the edge there of the bottom of our UV coordinates, we can see that the very top UV coordinate is basically sitting right at 0.56 on our vertical scale here. Now, if we select all of our shells and do layout, that's going to do an automatic layout for us. Try to fit it into the UV space as best as possible. We can do shift left click, however, to bring up the options. So we can do all sorts of changes to how the layout algorithm is going to work on the shells here. We can change the packing resolution, the number of times it tries to pack it together, and so forth and so on. All of this stuff was already inside of Maya and Maya LT. We can also do layout along a specific axis, so U or V. So in this case, it's laying out all of the shells along the U axis. We can change that to V, and we'll get the same thing. Last of all, we have our UV sets drop down, and this allows us to create and manage all of our UV sets. So obviously we have map 1 here. This is our default UV set with all of our shells here laid out. We can just create a new one, and we can then perhaps use some of our UV creation tools to create something new. So for instance, I'll select the mesh here in our viewport, and then we can go into our create tool and do automatic mapping, and now we have all of our shells laid out inside of UV set here. So we go back to map 1, we can see that we have the original layout, and then obviously UV set has the new layout. And of course we can right click that to delete it, duplicate it, or whatever the case may be. So let's cover some of the improvements to the Quad Draw tool inside of Maya LT 2017 Update 3. First up, when you select a live surface, you now have a drop-down that you can reselect that surface with. So we'll go ahead and set the body as our live surface, and now we'll set the eyes as our live surface. So now we can use the drop-down to switch between the two different live surfaces that we've chosen here. So we can see here we have body, and then we have eyes. Another cool thing about the Quad Draw Toolkit is the ability to actually use the Quad Draw Toolkit to create polygons that don't exist on a model that you've already built. So for instance, we'll go ahead and delete these polygons here on this mesh and leave a big blank spot in the middle. Now we can actually use Quad Draw to apply points to the surface, and those points will be basically created where Quad Draw expects them to be based on the rest of the mesh. So you can see here as I'm creating the points or the verts for our Quad Draw operation, they're actually they're floating above space approximately where Quad Draw thinks they should be on the mesh. And now we can just use the basic operation, shift click, to add the quads or polygons where the dots are. And this will of course fill in the rest of the whole of our mesh. So that's something that's new in 2017 Update 3. So when we look under the Quad Draw options, we have a lot of control over how Quad Draw works. We also have control over how it looks. So under Live Constraint options, we can see we have Mesh Color, Mesh Alpha, and so forth. Now, in the past, Quad Draw, when you would draw a polygon, it would render in a kind of a conflicting manner with the rest of the mesh. They would Z-fight. But now you can see that is not the case. No matter how large of a polygon I draw here, the Z-fighting is gone. So the Quad Draw rendering is much better in Maya LT 2017 Update 3. So you can see here, as I work on the Quad Draw frame, no matter what I do, it retains its position in the viewport relative to the base mesh so that there's no Z-fighting. It renders a lot better, that is. So you can see here I'm just dragging out polygons, drawing out Quad Draw polygons. I'm using basic operations here to basically just create a cage that would obviously replace a mesh that was too dense for being able to be used in game or in film. So again, no matter what I do here, it's maintaining its rendering above the base mesh. So there's no Z-fighting, no issues there. So you can see here I'm just cutting some more polygons in using all of the basic tools, all of the shortcuts that comes with Quad Draw. Now I can actually change the mesh color. So I can also change the alpha so we can make it fully opaque or, you know, completely transparent. And then we would obviously just see the frame. So we can change the color here to any color we want. Another thing we can do is use surface offset. So even though I've already begun drawing a polygon frame here with Quad Draw, I can change the offset. So this is actually going to start creating the dots offset from the base mesh surface, so that anything I do when I create other polygons here, they're going to be floating slightly above the surface. And that distance is obviously based on the surface offset distance, which right now I have set to 1. So if you wanted to create some sort of effect like clothing or armor above a surface, you could easily do that using the surface offset. And the great thing about it is that the surface offset, as you're creating your mesh, can be changed dynamically. You can go back and change it, you can reduce it, you can increase it, and then the polygons that you create will respect the offset. You can see here I've done one really high. Now the multi-cut tool has also been updated to work better with the Quad Draw tool. So you can see here that as I'm using multi-cut, it's respecting the base mesh as well, the shape of the base mesh, but it's also respecting the offset that I have set in my Quad Draw tool here, which is currently set to 3. So go ahead and turn that off and use the multi-cut tool again. You can see here as I'm adding edge rings, it's respecting the shape of the base mesh, and I can even draw through the mesh using the multi-cut tool, and it also continues to respect the shape of the base mesh. So it works a lot better now with the Quad Draw tool, whereas before, when you would use the multi-cut tool, it might not respect the actual base mesh. Also new inside of 2017 Update 3 is the ability to use the shortcut keys Control-Shift-X for multi-cut and Control-Shift-Q for Quad Draw, so you can easily switch back and forth between the two without using the buttons in the UI. So we can see here I'm just using the multi-cut tool to draw a shape and cut it into the frame, the polygon cage, and it respects the base mesh shape. Hey everybody, you've been watching part 2 of the Maya LT 2017 Update 3 Improvements walkthrough. Now we covered a lot of ground in this video. We went over the rest of the features found inside of the UV Toolkit and basic use of how to use those features, as well as covering the Quad Draw tool improvements. And those improvements included a visual upgrade to how they're displayed on a active mesh, as well as some of the other things that you can do using multi-cut tool and so forth. Now in part 3, we will cover some really cool new improvements to the viewport settings, to viewport 2.0, as well as displacement mapping, previewing the displacement mapping inside of the viewport, including complex shaders like ramps and so forth, shadows, point lights, shadowing, and so forth. So look forward to part 3, and we'll see you next time.